So on Wednesday, we talked about how to graph lines, and then we also talked about point y equals mx plus b, which is slope-intercept form of the line. And I've got all the different equations up here, or formulas for a line. We use y equals mx plus b when we are graphing lines. That is the point of y equals mx plus b that helps us graph. We've got our slope formula, which is change in y over change in x, which is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. This just means you're subtracting y values, and then you're subtracting x values. This is point slope form, and this is what we're going to focus on today. We use point slope form to write equations. You are given some information, and we use point slope form to write those equations. So that's what is going on with point slope form. Standard form is ax plus by equals c. We are not, it's just not that helpful, to be honest, to put a line in standard form. Your homework asks for you to put it in standard form, but I want you to get it into y equals mx plus b format. So it may be a situation where you look at my solutions over just the answers in the back of the book. Okay? So, so just know that standard form exists. Sometimes you might use it in 144, but even in 144 we don't use it that much. We usually focus on y equals mx plus b or point slope. So just want you to be aware of that. So I've got point slope up here written on my board. It's y minus y sub 1 equals m times x minus x sub 1. So you have the slope of the line and you have any point on the line. It does not matter which point on the line you have. You are going to get the same answer no matter which point that you use. Okay? So let's do some work with point slope form. Okay, we are going to find the equation of the line that has a slope of m equals 2/3 and has the point 1, 2 on the line. Okay, so our line has a slope of 2/3 and a point on the line is 1, 2. So what I'm going to do is I am going to use y minus y sub 1 equals m times x minus x sub 1. Okay, I am going to take my slope of 2/3 and I am going to plug it in for my m. I am going to take my point of 1, 2 and plug it in for x1 and y1. So I have y minus 2, and the reason I do 2 is because that is the y value of my point. Then I do 2/3, because that is my slope. Then I have x minus 1, and the reason I do 1 is because that is the y, or the x value of my point. Okay? Now what I do is I put this in slope-intercept form. So I have to solve for y. What is the first thing I have to do when I'm solving for y?
Get it by itself.
I do have to get y by itself, yes. So what do I do in order to do that?
Add 2.
Before I add 2, I have to do something. You're on the right track. I heard it. Somebody said it. Distribute. You distribute. So I've got to distribute my 2/3. Okay? So I have y minus 2 equals 2/3 x minus 2/3. And I got the minus 2/3 because I said 2/3 times x, 2/3 times -1. Okay? 2/3 times -1. Okay, now I add 2 to both sides. Now I'm hoping that we're doing a pretty good job with fractions, but I'm going to do the fraction work over here on the right, or I'm sorry, on the left. I'm going to do the fraction work on the left. Okay? So I have negative 2/3 plus 2 over 1. Negative 2/3 plus 2 over 1. Okay? I need a common denominator. What is my common denominator? Good. 1 goes into 3 3 times. 3 times 2 is it 6? Is 2 over 1 and 6 over 3 the same thing? It is. 2 over 1 and 6 over 3 is the same thing. Then I combine these and I get 4 over 3. Okay? So, once I've added 2 to both sides, I'm left with y equals 2/3 x plus 4 over 3. And so this is my final answer right here. That's my final answer. Okay, can we do another one? Okay. So, this one is slightly different. I am not given my slope. I have find an equation of a line where 3, 2 and negative 2, 5 are points on the line. Okay, so what is the first thing that I have to do here before I can do anything else? Find the slope. Okay, so that's what I'm going to do first. Find the slope of the line. Find the slope. Okay, so I'm finding my slope. I'm going to start with this point to find my slope. I have 5 minus 2 over negative 2 minus 3. 5 minus 2 over negative 2 minus 3. So my slope is what? Good. 3 over negative 5. Can you guys hear me over the pounding? Okay. Okay. So now my second step is going to be plug your slope and one of the points into point slope form. Okay, so that's my second step. Okay, so here is point slope. I've got y minus y sub 1 equals m times x minus x sub 1. Okay, now it does not matter which one of these points I use. I'm actually going to end up using both of them just to show you that it works. Okay, but I'm going to start with this one. You're going to get the same thing no matter which point you use. And I'm going to write up here that my slope, because I need a little bit more room, my slope is negative 3/5, so that I can erase this right here. Okay, so my slope is negative 3/5. So now I am going to plug everything in. So I have y minus 2. That's because I'm using this point right here. Okay, that's why I have y minus 2. Then I have my slope, which is negative 3/5, x minus 3. Okay? Now, my last step, once I've got it into the point slope form, is I am going to solve for y, and I'm going to put it in y equals mx plus b. That's the form that I want to go to. y equals mx plus b. So before I can put it in y equals mx plus b format, I've got to solve for y, and before I can add 2 to both sides, I need to distribute that negative 3/5. So I'm distributing the negative 3/5 first. So I have y minus 2 equals negative 3/5 x. Okay? Negative 3/5 times negative 3/1 is going to give me 9/5. Now I want you to look at exactly what I did there. So I did negative 3/5 times x, negative 3/5 times negative 3/1. So negative 3/5 times negative 3/1. A negative times a negative is a positive. 5 times 1 is 5. That's how I got that. Okay? Now, my next step is to add 2 to both sides. Okay. Now I'm going to do my fraction work over here on the right. I'm going to do it again right here. I have 9 over 5 plus 2 over 1. I've got to have a common denominator. What's my common denominator?
5.
Good. 1 goes into 5 how many times? 1 times what gives me 5?
5.
Good. 5 times 2 is 10. Is 2 over 1 and 10 over 5 equivalent? Yes, they are. So 9/5 plus 10/5 is 19 over 5. So that is what I write, and this is my final answer. Okay? Questions about that? Okay. I need to erase what's on this slide. Can I erase it? Am I good? Everybody got written down what they need written down? Okay. So, what I'm going to do now in a different color is I am going to show you what happens when we do the other point. So now I am going to do the same thing, but I'm going to use negative 2/5. Okay? And we're going to get the same answer regardless of which point that we use. So I have y minus y sub 1 equals m times x minus x sub 1. Okay? X sub 1, y sub 1 is any point on the line. Okay? So I'm using negative 2/5 this time. So y minus 5, because 5 is my y value of this point, equals my slope, x minus negative 2, because negative 2 is my x value of this point. What happens to the minus negative 2? Positive. Good. Becomes positive. Okay, so now I'm solving for y. So the first thing I have to do is distribute. So I have y minus 5 equals negative 3/5 x minus 6 over 5. Okay, so let's look at how we got there. I took negative 3/5 times x and got negative 3/5 x. Negative 3/5 times 2. So I've got negative 3/5 times 2 over 1. Okay, that is negative 6 over 5. Okay, now my next step, I add 5 to both sides. So I have y equals negative 3/5 x. I'm going to do my fraction work on the other side. I have negative 6/5 plus 5 over 1. Negative 6/5 plus 5 over 1. What's my common denominator? Good. 1 goes into 5 how many times? Good. 5 times 5 is? Good. Okay. So now we have 19 over 5. Is that what we got for the other one? It is. So it does not matter which point you use. You are going to get the same answer. Okay? Now we're going to move on to some word problems, but I just want to reiterate. When we've got y equals mx plus b, that is helpful for graphing. That is helpful for graphing. Okay? You use your slope pretty much for everything. Point slope form helps us to write equations. That's when we use point slope. And a lot of times your directions will say, write your answer in slope intercept form. Okay? Now you'll be given these formulas on your test, but you do need to know which one to use for what. So that's important. Okay. Now, the really super nice thing about linear equations is we can find evidence of them in real life everywhere. Okay? You use it in psychology. You use it in business. You use it in your sciences. You use it in medicine. Okay? So evidence of linear equations are everywhere. Now, one of the things that happens is you have to be told that it is a linear relationship. Okay? There are other relationships. Do you remember when we talked about the car dropping in price as soon as we drove it off the lot? That is actually an exponential relationship. It drops so fast that it's not even linear. It drops and then it evens out. So the depreciation of a car is exponential. So you have to be told that the relationship is linear, or you have to be given the linear equation that represents it. Okay? So here, I've got digital solutions charges for help desk services according to the equation C equals 0.25M plus 10. C represents the cost, M represents the minutes of service. Complete the following table. So you can pull out your phone and you can use your calculator, but I want you to figure out how much money it's going to cost you to be on the phone with the help desk for 5 minutes. So you are going to plug that 5 in for M. So you're going to do 0.25 times 5 plus 10. Then for 10 minutes, you're going to do 0.25 times 10 plus 10. 15 minutes. 0.25 times 15 plus 10. And you can use your phones for this. So I'm going to give you about 3 minutes to fill out this chart. Does anybody have the cost for 5 minutes?
$11.25.
Good. Okay, what about 10 minutes?
$12.50.
Good. I don't write small enough, so I'm kind of alternating up and down. 15 minutes.
$13.75.
Okay, 20 minutes.
15.
30.
17.50.
And 60.
25.
Perfect. Okay. So that is how much money it would cost you to be on the phone with tech support or the help desk for any given amount of time. Now, if you have multiple questions for tech support or the help desk, is it better to call them 3 or 4 times, or is it better to stay on the phone with them once and get all your questions answered?
Once.
Tell me why.
Because if you would call back again, it's just going to keep multiplying the cost up.
Good. What do they charge because you say hello?
$10.
$10. Okay? That's what that plus 10 is. Okay? There's an initial cost of $10. That doesn't matter if you're on the phone with them 5 minutes or an hour and a half. It's $10. Okay? So it's better to be on the phone with them one time for a longer period of time than it is to call them back for several short periods of time. Now, what we are going to do now is we are going to create a graph. Okay, we're going to sketch this. Now, we are used to sketching lines where we've got 4 quadrants. We didn't talk about this, but this is quadrant 1. This is quadrant 2. This is quadrant 3. And this is quadrant 4. A lot of times when you're talking about real world situations and real world applications, all of that takes place right here in quadrant 1, and this situation is included. Because these are our positive x values, and these are our positive y values. Because very often, our positive x values are talking about time. Do we have negative time? No. Okay, you can't be on the phone with tech support for negative 5 minutes. Somehow they would owe you money, and I don't think it's going to happen. Okay? Now, can you be charged a negative amount of money for being on tech support? No. Okay? So that's why we're hanging out only in this quadrant right here. So you are going to draw your positive x values and your positive y values. That's what we're going to do here. Our positive x values and our positive y values. Okay? It's telling us that we are going to label the horizontal axis M and the vertical axis C. Okay? That's telling me that this is minutes and this is our cost, which is our money. Okay? A lot of times we still think about this as our x and this is our y. Okay, in science, it'll be called your independent variable and your dependent variable. Okay, but in this situation, they're telling you what you're graphing here, but you can still think about it as the coordinate system. Now, we've got 5, 10, 15, 20, 30, and 60. Does it make sense for each one of my little tick marks to equal 1 minute? It doesn't.
No.
Okay? It does not, because we'd have to have 60 of them. So I'm actually going to do 10s. You could do 5s. I'm actually going to do 10s. So this is going to be 10 minutes, 20 minutes, 30 minutes, 40 minutes, 50 minutes, 60 minutes, and 70 minutes. Okay? So it's not always easy to write down the value of every single tick mark, and that's okay. What value should we put each tick mark under cost, or my Y value? I've got 11.25, 12.50, 13.75, 15, 17.50, and 25. I would do 5s. That's what I would do. Okay? So I'm going to have $5, $10, $15, $20, $25, and $30. Okay? So you need to label some of them so that we know what each one represents. Now what we're going to do is we're going to plot these points. So I have 5 minutes, and 5 minutes is going to be let me see if I can make this a little bit darker. Let's do that. Okay? 5 minutes is going to be about right here. Okay? Do you see that mark right there? 5 minutes is going to be about right there. Okay? And I need to go up to 11.25. So 11.25 is going to be just past my 10. Okay? So that's going to be my first point on my line. It's about right there. Okay? The next point is 10 minutes. This is 10 minutes, and we're going up to 12.50. So it's going to be about right there. 15 minutes is in between my 10 and my 15. Do you see it right there? So I'm going up to 13.75. I have not hit 15 yet. So this is a very shallow line right here. I'm still under 15. I don't hit 15 until I get to 20 minutes. That's when I'm at the 15 mark. Okay, 30 minutes is 17.50, so that's in between 15 and 20. And 60 minutes is 25. Okay, so here is our line. There's our line. Now, when we use the graph to approximate the costs, we are still guessing. The graph gives us an overview of what it's going to cost. So what I'm being asked to do in part C is use the graph from part B to approximate values for C. So we are approximating. Okay? Approximation means that we are estimating. Is it possible that we don't figure it out exact? It is. So the first thing that I'm supposed to figure out using the graph is we are going to approximate how much does it cost for 25 minutes. Now we are using the graph for this. So I am going to look at my graph and I'm going to go to 25 minutes. And 25 minutes is about right here. Okay? So, am I above 15 at 25 minutes? Barely. Barely. So what would be a reasonable approximation for 25 minutes? 16. Okay? 16. Okay? Now, let's look at 40 minutes. $16. 40 minutes. Okay? We're looking at our graph. Okay, are we at 25 yet for 40 minutes? No. Okay, so what's a reasonable approximation? 19. Are we above 20? No? Okay, we may not be. I'm sorry. I may have. It's sometimes my drawing's not perfect. Well, all the time my drawing's not perfect. Okay, then 45 minutes. 45 minutes, where are we? So if this is 40, this is 45. Where are we for 45? Are we at 20? 20, 21? Okay. So we are still approximating. We are estimating based on this graph. And this is a graph that I drew by hand. When you do them electronically, sometimes they're easier to read. But we are approximating. What did we say, 20 for 45? Okay. Now, is there a way that I can find the exact cost for 25 minutes, 40 minutes, and 45 minutes? Is there a way I can find the exact cost? What do I use to find the exact cost?
Plug in the
Plug it in. So I want you to do that right now. Using your calculator, plug in 25 minutes, find out exactly how much. 40 minutes, find out exactly how much. And 45 minutes, find out exactly how much. How much for 25 minutes?
16.25.
Good. Were we close?
Yes.
We were. 40 minutes?
20.
And 45.
21.25.
Good. Were we close?
Yes.
Yeah. Okay. Now, which one of these things do you think tech support uses to charge your credit card? Yeah. They're going to make sure they get every penny, right? And they're going to round up whenever they have the opportunity. If you hit 14 minutes and 2 seconds, you're going to be charged for 15 minutes. Okay? So, graphs are very helpful because it gives us a visual of what's going on. But when you need exact, then you do want to plug that into the formula to get the exact value. Okay? So this is a linear representation of what you would be charged if you called a help desk in this situation. And there's lots and lots and lots of linear representations. This is probably a business representation more so than a technology representation, but it's used a lot in business. Okay? Now, the next one that we're going to do is we are going to be asked to come up with an equation, just like we did earlier today. So this is a medical example. Okay? You have to be told that there is a linear relationship. It says, the situations can be described by the use of a linear equation in two variables. Do you see this right here? If two pairs of values are known, then we can determine the equation by using the approach. And that just tells you what example in your book. So, here we've got a diabetic patient was told by her doctor that her hemoglobin A1C reading of 6.5 corresponds to an average blood glucose level of 135. There is a relationship there. Okay? Her 6.5 reading, hemoglobin A1C, and that's a real test that you have done when you go to the doctor, okay, corresponds to a sugar level of 135. Okay? At her next checkup, 3 months later, the patient was told that her hemoglobin A1C reading of 6.0 corresponds to an average blood glucose level of 120. So this diabetic patient did some right things. She got her A1C down. So that's a good thing. Let Y represent the average blood glucose level and X represent the hemoglobin A1C. Okay? So X is our A1C values. So this is important right here. We are told, let Y represent the average blood glucose level, and X represent the hemoglobin A1C. So here is a relationship right here. What is the X value of that relationship? Is it 6.5 or 135?
Oh, 6.5.
It is 6.5. Her hemoglobin A1C reading of 6.5. And then we're told down here, X represents the hemoglobin A1C. So it's 6.5. And what's the Y value?
135.
Okay. Now, my second point then is 6.0 and 120. Now, using our point slope form, we can now get a linear relationship between the A1C value and your average glucose over that month or 3-month period that they look at your A1C value. So, we are going to find our slope. And you are going to want to grab your phone for this. So we've got our change in Y over our change in X. So I'm going to start with this point. So I have 135 minus 120 over 6.5 minus 6. Okay? So I get 15 over what?
45.
Okay, do that division. When we are doing real life situations, you want to have, and sometimes it turns out to be a decimal. It doesn't in this situation, but sometimes it does. What is 15 divided by 0.5? 30. Okay, it's 30. So I can use either point. So I'm going to do y minus y sub 1 equals m times x minus x sub 1. And I can use either one. It doesn't matter. Okay, I'm actually going to use my second one for this because I'm not dealing with any fractions. So I'm going to use the second one. Or decimals, I'm sorry, not fractions. So I have y minus 120 equals a slope of 30 times x minus 6. Y minus 120 equals 30 times x minus 6. Okay? So y minus 120 equals 30x minus 180. Is that what that is? 6 times 30. I add 120 to both sides. And my final answer then is y equals 30x minus 60. And what that tells me is this is the linear relationship between your A1C values and average glucose values. That is what that's telling me. Okay? So this right here is my final answer. Now, once I had this y equals 30x minus 60, could I then take a hemoglobin A1C of 4 and predict what the average glucose would be? Or an A1C value of 7? Could I do that once I've got this? I can.